Hello everyone, welcome to Rangle.io's webinar on components in Angular 2. My name is Seth Davenport. I'll be your presenter today. Might as well get started. So we're going to talk a little bit about component-oriented architecture and show some examples of what that means in Angular 2. Component-oriented architecture is a sort of way of thinking about your views where you describe your application as a tree, essentially, of granular UI components. Each of the components can be thought of a custom HTML tag that you sort of build yourself out of JavaScript and CSS. You can kind of think of it as building a domain-specific language for your application. This isn't a particularly new idea. It comes from some work that was done by the Web Components people and Google Polymer. It's been kicking around for a couple of years now. But it's only recently become sort of a mainstream way of thinking. Angular 1X supported in a limited way with directives. React.js kind of brought it into the mainstream, but it's the central concept of building Angular 2 applications. And we'll talk about that today. So if any of you have worked with Angular 1.x, you probably are familiar with this pattern where you use directives to build these components. It's not a natural fit for the directive. It's a leaky abstraction. You have to be careful to encapsulate your components so that they're properly reusable. But this is a design pattern that got very popular, and so popular, in fact, that in Angular 1.5, Google introduced the dot component, sort of a syntactic trigger to help you build more encapsulated directives or components. But then once you've done that, you basically have new, essentially DOM elements that you can build your application out of in a very composable and reusable way. And this turns out to be a very powerful model. So in Angular 2, this way of thinking is very much the default in the framework. So this is an example of exactly the same component in TypeScript with Angular 2. And you can see a few things immediately. You have this @component thing, which is an annotation. And it basically just attaches some metadata to your controller class, which is right here. And this component contains everything it needs to know to render basically a widget of your UI. We have a selector, which is how it will be named by the templates that want to reference it. It knows about its own HTML structure. It knows about its own styling. And this one doesn't have any real logic, but if it did, it would know about that too. The goal here is encapsulation. We can take a look at running this live in Plunker. Since this is the first one, I'll talk a little bit about the setup. In this case, for demo purposes, we've chosen to bring in Angular with a content delivery network. And then we're using System.js and the TypeScript transpiler to allow us to write TypeScript code and transpile it on the fly to ES5, which the browser understands. There are a number of ways to do this in real life. If you want to see an example of a production setup using Webpack, you can go to Wrangle's GitHub organization and look for the Angular 2 Redux starter. But this one is good enough for now, certainly on Plunker. And here's the component that we just talked about, basically exactly what I said. And it renders itself, it knows about its structure, its content, it knows about its style. And it's a nicely granular, if contrived, encapsulated component that we can use. So when we're building apps with Angular 2, everything is components. It's components all the way down. The framework requires that you build one top-level component, the bootstrap component, but everything else can be very granular. And this leads to people separating their components into presentational ones and logical ones. Most of your render tree will be little presentational components, very little logic, very little state, really just markup and styling, but they are highly reusable. And this sort of way of thinking about applications comes from the design world, in particular a design approach called atomic design. There's a good blog post about it by Brad Frost, which I encourage you to read. But what's interesting is that developers and designers now are meeting in the middle. Well, we're converging on components because it's just a natural way to think about UI on the web right now. So here's a quote from Stephen Hay. He's a contributor to A List Apart, fairly noteworthy in the design community. We're building up our UIs from very granular components that are highly reusable. They incorporate the design and branding at the lowest level. Designers have been doing this for ages. Developers are now starting to catch up with them and make the code reflect that. So we'll talk in this webinar about building some of these components from scratch with Angular 2. We're going to talk about the concept of an atom, which is a very low-level, styled, branded UI element. And we're going to build some of those, and then we're going to look at how to sort of pass data in and out, and how to encapsulate them, and how to make them very reusable. When you make a bunch of atoms like this, they form essentially a living style guide. So instead of your designer having a static document where he's got all the sort of colors and fonts sort of written down for you, you now have the ability to actually have this thing in code. You just put all your widgets on a page, and now the entire team has that basis for how to build the UI. And it's actual code, so it stays up to date with the state of the project. So we'll start with these sort of design atoms, and we'll combine them into molecules like this search bar that do something a little more interesting, and they will get put together in pages in the final state of your application. An important thing to note is that presentational components, atoms, they're very simple, but they're also extremely reusable. As soon as you wire more and more things together and add in more logic, things become more special purpose and thus less reusable. So what we're really trying to do with this architecture is spend most of our time on the left side of this chart. Lots and lots of simple reusable components and relatively few top-level complex components with logic in them. So we're talking about essentially two kinds of components: container components and presentational components. Container components are essentially your page-level things. That's where the business logic exists. We won't talk too much about that today. That's the subject of a future webinar. The meat of what we'll talk about today is your presentational components, your simple, highly reusable branding and widget UI elements. So let's take a look at one of these atoms from earlier, the label atom. This is a very simple component, but we do need to be able to pass some data into it in order to make it properly reusable. Unlike in Angular 1, things in Angular 2 are very strongly encapsulated to begin with. There's no hierarchy of scopes where you can implicitly pass data around. You have to be very explicit about what's flowing into your component and what's flowing out of it. So let's take a look at this. We have a controller class here, Rangle label, and we've declared a member variable and we've tagged it as an input with the input decorator that we import from Angular. This tells Angular that this is something that's going to be bound into different instances of this component in the different places in the page where it lives. Our component also knows its own template, its own HTML. So in this case, it's just a HTML element with quite a bit of styling. And then we bind the input name, or the member of this class, using these double curly brackets, which in Angular terminology is referred to interpolation. And here's an example of where that component, or how that component might be used. Right. So here we have a top-level component that's including our Rangle label in its template, and it's using it as it were as any other HTML element, which is of course the power of this model. We're using the square bracket syntax to map a variable or a value into our Rangle label's name input. And that's how we make a reusable component that accepts some input. So let's take a look at that running in the browser. So here we go, similar setup as before, except this time I have put in our top-level component, which is using our Rangle label, which we import from the file where it's defined. We use the component directives property to tell Angular that our hello component is going to use Rangle label. And that's it. We just pass in whatever we want into that component. And if I look at the implementation, it's the same as we discussed on that slide. We've made name an input, which means that our parent component can actually pass stuff to it. And it is referenced in the template using interpolation. So we can say in Angular terminology that our parent component is binding the name property of the Rangle label class to this variable which contains text. This doesn't strictly need to be a variable. You could always use this syntax where you just put text in directly. But I wanted to showcase both approaches. This is a static thing, it will never change. The previous approach would allow us to actually dynamically change the value of name at runtime, which is of course handy in any larger app. So that's for getting data into a component. In order to make components sort of reusable and valuable, we also need to get stuff out of them. And Angular does that using events. So let's make, our second atom here, which is the actual styled button, the primary button. And once again, we do that by defining a component decorator on a controller class, which I will show you in the next slide. It has its own HTML template, which is in this case an HTML button. As before, we've used interpolation to bind an input name onto it. But we are also using this sort of parenthesis syntax, which is event binding, to bind an expression that gets evaluated anytime the button is clicked. This refers to the HTML DOM elements click property, which is of course given to us by the browser. And then of course the component also knows about its own styles. So if we look at the actual TypeScript code for that, the actual class, the component decorator would actually be right here between the import and the export statements. And we've defined our input name exactly as we did for the label component. We've defined another input which we're actually using to control some styles dynamically, whether it should be a red primary button or a purple, normal button. And we're using the new output decorator and a property which is an instance of event emitter to actually fire events up to the consumer of our component. So this is where this onClick.emit comes from. It's from the event emitter. So that's how you essentially send clicks or other actions or events out of a component and up the chain, up the tree of UI that is using it. I've also included an example here of dynamic styling. If we have the isPrimary property set to true, we will use one CSS class. Otherwise, we will use a different one. And that's how we control the primary coloring. So let's take a look at that running in the browser. So here we are, and here's our component just sitting there. I could, in theory, create another one of these, but maybe set is, remove the isPrimary. Maybe put some different text on there. And now you start to see how this component is in fact reusable. And when you click on it, it gives you an alert as per the code. So that's input handling and event handling. But we also need to get actual data out of some components. A classic example of that is an input component. So if we go back to our little atom list here that we want to build, we've also got a text input which we will build out. And so here's the component decorator for such a thing. We call it Rangle text field. We bind the input's placeholder property to some text which will be defined on our controller class. And then we hook it up to handle key up events. This octothorpe syntax here, the hash sign, this is declaring a template local variable. It just allows us to access the value of the input in our expression. And here's the actual TypeScript class for that component. As before, we've got an input. That's how we're getting our placeholder text in there. We've got an input for our initial value for the control. And then we've defined an output value change event emitter as before, except this time this is an event emitter that can emit strings. So then every time a key up event occurs inside the control, we emit the full value of the control to whoever is listening to our value change event. One thing to note is the naming of our input and output here. We call the input value and we call the output value change. This is a sort of advanced feature of Angular that allows our parent component to use this special syntax for two-way binding. So essentially, recall that the square bracket was input binding and the round bracket was event binding, so output binding. So this way we're basically saying we want both bindings on your field called value, and what we're going to do is when value change events are emitted, we're going to unbox them, or actually Angular 2 unboxes them for us and puts them in display value on our class. So we can take a look at this in real life. And so here we are. Here's our input text field. Our application is saying two-way bind the value of the input to the class and then display it in this paragraph element. So now I can type in here and everything updates as you would expect for two-way binding. So now we've got our three sort of atomic components that we talked about before. Let's combine them. Let's combine them into a so-called molecule, a piece of the site that just does a little bit more. So look at this piece of TypeScript. We're importing our custom atoms from our folder that we created. We are telling so we're creating a Rangle search bar component, and we're telling it that it's going to use our custom directives in its template. Because the template and the CSS now are getting a little bit big to fit on one slide, I took the opportunity to show you how you can actually include them from external files, which is a good way to do it once things start to get large. You can do it for templates and you can do it for styles. And our search bar, has a function that's going to make a window alert whenever you type something in the text box and then click the button. So here's what the template looks like. Once again, this would live, in the external template file. As you can see, we're just using our atomic components, as if they were regular DOM elements. We're starting to compose our application, our UI, out of smaller parts. So we're including a label with search the site as its text. And then in a row below it, we're including a text field with some placeholder text. We're binding its value to our search bar controller. And then we're including a button, and when you click it, our controller's handle search method will get called with the value of the text field. And then we apply some styling to our search bar. It's sort of a judgment call sometimes whether to put the styles in the actual atom component or whether to keep them at the level of the component that's using them. And the rule of thumb really is related to encapsulation. Components should be able to render themselves without any extra help. But components that group those components together should be responsible for the layout of the children, which is why I've included some flexbox stuff here, some margin stuff. You can also note that you can use the :host selector to style the root element of the component itself, which is sort of a handy feature. Let's take a look at that. So here you can see a much larger plunker. I've included all of our atomic components from before. There's the button. There's the Rangle label. I've included the Rangle text field. I've included the search bar with its separate TypeScript and HTML and styling. And you can see it all rendered over here on the right. And so at this point, our application is rendering a search bar component. And that search bar component renders the three atomic components that we used before. So we really are building our application now as a tree of components. And as you can see, it works. I can search for something. And when I hit search, we get the alert as expected. So here's an interesting thing to keep in mind. Everything we've built right now has been stateless components. Even the search bar, they just take inputs and outputs, and they produce DOM, and they have no side effects. This is important. Statelessness is one of the things that will help you keep your low-level components very reusable. Later in the webinar series, we'll talk about some solutions for managing your state at an application level, but really it's best to keep it out of the view. So you might be, thinking this through and starting to visualize your application as a potentially very deep, very complex tree of UI components. And you might be thinking, sounds annoying to sort of pass all those inputs down the chain and pass all the outputs back up to the chain so that you can keep your logic at the top level. And that's true, which is why I'm going to talk about projection next. Projection is a technique that can help you make your components even more reusable and make your UI trees flatter and more manageable. Let's revisit our Rangle search bar example using projection. We'd like to pull out some of this placement and layout and styling into a standalone component called Rangle bar, which we could then use for a variety of things. We're going to do this using projection. Now the way to do that in Angular is to use Angular's built-in ng-content component. Essentially what this does is it serves as a placeholder in your components template, such that if your application uses that component but includes some DOM elements inside the invocation, those DOM elements, those children, will end up where this ng-content is placed. So imagine we have a component selector as before, with an external template and styling file. Much of this is very similar. We're just extracting the layout and styling portions of the search bar into a standalone component. Then our application can actually use this Rangle bar with arbitrary DOM children. So we can construct a search bar out of it, but we can also use that bar and stick other stuff in there. And so now we've encapsulated the layout portion of our search bar in a reusable way. And here's a demo. As you can see, Our application has created 2 instances of Rangle bar, one with the search contents as before, and it works just as before, and the other one with, potentially other stuff. We're essentially recycling the bar styling and internal layout into something that can be used all over our application in different ways. So projection, once again, has helped us break down our components, make them more granular, encapsulate little bits of presentation in a very modular, reusable way. And this is really the power of the component architecture. So I would say that good use of projection is the second key to reusable components. There's actually quite a lot more you can do with projection. This is a fairly simple example. I can fire up a more advanced demonstration. What you can actually do is, with the ng content component, you can essentially have several of them, and you give them a selector, which essentially boils down to the same language as a CSS or jQuery selector. And that way you can define several spots in your layout component where different children get placed at runtime. So for example, here we're saying, this ng content, I want you to put any children that match the header selector in this area. And so if we go down to the place, to our app where this component is used, you can see that here's our projection component, and inside it we've got some content in a header tag. So this header content will get put in the ng content area that is selected by header. So you can do that with an element name selector, like we've done with header and section here. You can do it with a class selector. You can potentially do it with an ID selector. So this is a very powerful and flexible way of building reusable layout components. It's one of the nicer features of the framework, in my opinion. So this is all well and good. We've talked about how to encapsulate the HTML parts of a component. We've talked about how to encapsulate the JavaScript or TypeScript logical parts of a component. But more astute listeners may be asking, how do we properly encapsulate the styling of components? CSS suffers from the fact that all of its selectors and definitions are global, and this usually leads to a big mess, making it very hard to break down presentation into reusable chunks that don't interfere with each other. We've all had that experience where we've tried to change the text on a button and broken a form somewhere else in the application. Well, Angular 2 gives us the tools to do this properly as well, using the concept of view encapsulation. Let's take a look at some code here. Imagine if I had, an Angular application with a main index HTML similar to the following. I've excluded for brevity all the places where we're importing the libraries and whatnot. But essentially what we said is globally in CSS, anytime you see a paragraph element, I want you to render it with a dashed blue 2-pixel border. Then imagine later on somewhere else in the app, in our app component, we use a paragraph element, and we've defined completely different styling for that paragraph element. In this case, we said, I want you to have a red background, and we said nothing about the border. You might expect this app to render 2 paragraphs, both with dashed blue borders and both with red backgrounds. However, that's actually not what's happening. This is a live demo of that preceding code. The paragraph element that's inside the component gets both the global styling and the component styling, and the paragraph element that's outside the component only gets the global styling. Well, this is very counterintuitive, right? CSS does not normally work like this. So what's going on? Well, it turns out that AngularJS actually modifies the CSS definitions that you put in the styles property of the component decorator. It does it very cleverly. First, it assigns a quasi-unique attribute to your component's DOM, and then it modifies your styles to only apply to things that have that attribute. So effectively what Angular is giving you by default is scoped CSS at the component level, which is great. It means that you can style your components specifically without worrying about name clashes, without worrying about the global nature of scope. So by default, your Angular components will get any global CSS defined at the page level, and they will get their own component level CSS, but they will not get any other CSS from any other components. This is a very good default, in my opinion. It's generally speaking what you want 9 times out of 10. So this idea of view encapsulation, which is what they call this scoping of styles, in my mind it's the third key to making reusable atomic components. Of course, if you don't like it, you can change that behavior. And you do that by importing the view encapsulation enumeration from Angular and telling your components, to use different values for it. Currently, there are 3 values provided by the framework. There's emulated view encapsulation, which is the default, and this is what we saw on the last slide. In this case, you will get styles from the global HTML page, and your component will get its own styles, but it will not get styles from other components. You can turn it off completely, in which case your component will get styles from the main page, and all other components will be affected by this component's styles as well. This breaks encapsulation. I would encourage you to hesitate before using this. And then there's native view encapsulation, which is the strictest form. Your component gets its own styles and no others. It does not get styles from the page. It does not get styles from other components. Let's take a look at this in action. So here's the example I presented a couple of slides ago using the default view encapsulation. So to recap, our index.html says here's a global paragraph style with a dashed blue border. And then our app component just renders another paragraph with a red background. So our template at the end of the day has a paragraph that is not wrapped in any component, it's just there on the index page. And it has a paragraph that is wrapped inside a component. And the one outside just gets the global styles, and the one inside gets the global styles and its own styles, because we're using the default, which is view encapsulation emulated. Now if I change this to view encapsulation none, suddenly you can see that the app styling has become global. The paragraph that's outside the component is now affected by it. If I change view encapsulation to native, you can see that the 2 sets of styles are now completely disjoint. The paragraph that's outside the component gets the styles from the index page, and the paragraph that's inside the component only gets its own styles. And again, this is done essentially by Angular doing some sort of magical trickery transformations on your component styles. Anything that's assigned effectively to this property for any component. So at this point, we've seen 3 excellent tools that Angular provides you for keeping your components nice and reusable. View encapsulation, or scope styling. Projection, which allows you to define components that essentially just do styling and layout for their children. And finally, statelessness, or components as pure functions of input and output properties. Yeah, these three things should get you a long way. You should be able to build, a good chunk of your application just in this very reusable, stateless, scoped kind of way, and I encourage that. Angular lets you do a few more powerful things, though, than that. Once you start getting up to the top level of your application, at the page level, you're going to want to start hooking it up to, AJAX calls, a state management solution, what have you, subscriptions to events, all kinds of things. And for this, Angular gives you a component lifecycle which it manages for you, providing you with hooks so that you can tap into various stages in a component's lifecycle. When it's created and initialized for the first time, when changes happen, when it's destroyed. These are all pretty well documented in the Angular 2 documentation. Typically, the ones that you'll find yourself using are ng-on-init and ng-on-destroy, generally to subscribe to observables or events, and then to unsubscribe when your component is no longer needed. The rest of them, ng-do-check, etc., will come into play if you want to write your own custom change detection strategy, which is outside the scope of this webinar. But it's good to know that they exist. And it's good to know that you can actually tap into them, as I can show in this example. Here we've created a component. We've imported a number of interfaces that define these various lifecycle hooks. And then we can just go ahead in our controller class and implement them, and logs will happen at the appropriate times. So you can see that we got called when something changed. This was the initial setting of the input property. We got called after the first set of changes and the first render of the component. We got changed later when we actually updated the property, and we got called when the component is destroyed. And finally, another advanced topic is DOM manipulation in Angular. In general, and this is also the case in Angular 1, direct DOM manipulation is not encouraged because it sort of breaks out of that nice component-oriented way of thinking. It gives you sort of unfettered access to the browser's engine, which you can use in ways that become hard to maintain, right? If you do this stuff too much, I mean, you might as well just be writing with a jQuery, because that's effectively what it gives you. However, there are times when you need to, when you're interfacing with third-party libraries, where you have some other compelling reason to access the DOM. Angular gives you a tightly controlled but powerful way of doing that in the form of ElementRef. ElementRef is a service that you can import, and you inject it into your controller, and it basically gives you access to the DOM element at the root of this component instance's template. So this is very similar to using $element or the other arguments of the link function in Angular 1. So as I mentioned before, I encourage you to use this feature sparingly. It really is sort of an escape valve for when you need to do something exotic. Here's an example. This is a component that is actually able to display its own DOM, which is sort of clever. I could see this being useful for a view source component, or if you did it on SVG, it would be a convenient way to actually download a dynamically generated SVG. But it's just using ElementRef, using it to essentially clone its own DOM nodes, and then display them in a code block. So to wrap up, in this webinar, I tried to give a sort of background introduction to component-oriented architecture and atomic design. Try to encourage you to build your Angular components, your Angular applications as trees of simple granular components that have everything needed to render themselves, including HTML, CSS, and JavaScript. This is maybe a break with traditional ways of doing web pages. We're no longer separating concerns by which technology they're implemented in, but instead we're separating concerns by actual UI widget level functionality. So we've gone from keeping our CSS in one file and our HTML in another file and our JavaScript in a third file to actually breaking it up by UI widget, which is a much more natural and maintainable way of separating concerns. Presentation is an important part of that functionality, so we can now start to bring in designers and actually work with their style guides and their componentized way of thinking directly in the code base, which brings those two parts of the team closer together. I talked about some tips for keeping your code reusable, keeping your components reusable. Statelessness, components that are only, they're essentially pure functions of their inputs and their outputs and have no side effects. Talked about using projection to keep things generic, to keep your component tree nice and flat. I talked about using view encapsulation to work around the problems with global CSS. And I showed some examples of small and granular components and how to compose it into doing something a little bit more useful. I also talked about some advanced features that Angular provides when you need to do stuff that's more exotic, including ElementRef for DOM manipulation and Lifecycle hooks for sort of the initial wiring together of apps that need to subscribe to events or make server calls. So with that, we have a little bit of time left. I'd like to give people the opportunity to ask me questions. I would say the easiest thing is probably to put them in the chat, and I will try and address them. Okay, there are quite a number of questions, so I'm just going to try and go through them in order. The first one is, what's the best way for data flow between a parent and a child component? Is an injectable service the best practice? This comes down to a broader architectural question. Typically, I tend to prefer using a state management solution like Redux or Flux, in which case data flow from parent to children happens strictly through input and output properties. And I try to use projection to keep the tree flat, so I'm not doing a lot of boilerplate, passing things down level to level to level. However, if you're using a more traditional architecture with services and things like that, that's also a perfectly reasonable approach. You can keep your state in services and inject those into the components as needed. It's just the best thing is to think carefully about which components need which state so that you can try and keep them reusable. Another question is about event emitter. Does it emit an event to the whole app or just to the parent component? Event emitter emits it to anyone who's subscribed. Because we tag it with an output property, essentially the people who can subscribe are the people who have created that component and therefore able to register an event handler on that component as an attribute using the round bracket notation. A third person asks, is there much difference between TypeScript and JS in Angular 2? Which is the preferred language? You can use Angular 2 with both, or with three different things, I guess, really, with TypeScript or with ECMAScript. 5 or with ECMAScript 6. The recommended approach is TypeScript. Angular 2 is built in TypeScript, and it provides a lot of syntactic convenience. If you use ES5 with TypeScript, you're not going to have the component decorators or the class syntax. So you're going to be writing a lot more boilerplate. You have to set properties on constructor functions manually and mess around with prototypes. It can be done, and I believe the Angular documentation shows some examples for TypeScript, regular JavaScript, and for Dart. But the preferred language is TypeScript, and I encourage you to investigate it. It has a lot of really nice features. So another question is, what's the :host selector in CSS? So I touched on that briefly, but essentially it allows you to apply styles to the root DOM node of your component. So for example, if I have the Rangle input component, Angular actually renders in the DOM essentially a top-level div, effectively, with that template inside it. So :host allows you to select that div. Another question is about projection. Is it a feature of Angular 2 or is it not? Yes, it definitely is. The ng content DOM element, essentially, that you use to tell Angular where to put children is included in the Angular framework. It's one of the built-ins. So somebody asks, are atoms equivalent to DOM elements? So atoms are just whatever you define them to be, right? They are your lowest level of component. And when you're using them in other parts of your application to build out a tree, in those templates you will use them exactly like sort of custom DOM elements. But when they're rendered into the page, they may contain, arbitrarily complex templates. Somebody asks, with projections, what would happen if a background color was defined in both places? So I'm assuming that you mean the parent component and then the projected children. So what would happen? I mean, it sort of depends on your view encapsulation settings, but by default, let's say if the parent component had a background color of blue and the child component had a background color of green, I would expect to see the whole the whole parent component showing up with a blue background, and then the portions of it that belong to the child would be green, as if you had just nested it regularly in HTML. But I mean, that depends on the specifics of your CSS. Somebody asks, is it possible to create any custom events in Angular 2? Essentially, yes. With the output decorator and event emitter, you can emit any event anytime. It doesn't have to be attached to a built-in DOM on click or what have you. So in that sense, they are custom. Somebody asks, what are your thoughts on using the built-in TypeScript compiler interpreter in Angular 2 versus building TypeScript via an IDE in Visual Studio that supports TypeScript compilation? I'm not sure I know what the built-in TypeScript compiler is. As far as I know, there's only one TypeScript compiler, and that's the one that comes from Microsoft. So then the question is, do you build it into your IDE? Or do you transpile on the fly like we've done in our examples using Plunker? My answer to that is it just really depends on your needs. In production systems, what we actually tend to do is write our code in TypeScript and then compile it all bundle it all, minify it all, using IDE tools or even command line tools, and then we deploy that bundle. That way everything's done at build time and not at runtime, so performance is better. For quick demos like what we've done today, using System.js to transpile in the browser is easier to get started with and get set up with. If you want to see an example of production bundling and minifying, I encourage you to go to our website, go to our GitHub. So github.com/Rangle, and you can search for a repository called Angular2-Redux-Starter. And that's actually our sort of production toolchain all set up for you with Webpack. I myself use Visual Studio in that environment, but I use Visual Studio for syntax highlighting and linting. I tend to do the actual compiling and bundling on the command line, but that's just my workflow. Somebody asks if I can share the link for the Atom-based architecture again. I can hook that up. Well, actually, what I'll do is a number of people have asked if they can get access to the slides. I'll make sure that happens today, and then you can get the link out of there. Someone else asks, is there a way to address component media queries? Absolutely. The styles decorator, the AComponent styles property, what you put in there is straight up CSS that we would write any other way. So if you put media query in there, it will get applied to that component. That's one of the nice things about it. Unlike with React, where you often have to mess around with various tools for that purpose, in Angular 2 it is straight CSS. You're just putting it into your component. Somebody asked, how does UI routing influence component architecture in Angular 2? This is actually a great question. Angular 2 supplies a router that they've rebuilt from the ground up. It takes some ideas from the old UI router, but it is very component oriented like the rest of the framework. So essentially what you do is on your top level application component, you have an @route config decorator where you essentially map UI routes to the component that will be rendered there. So if you have a top level component for each page of your application, that's where you're actually going to wire it up to a path on your URL. They've actually backported this router to Angular 1.5. It's called Component Router, because it's just such a natural fit for the way people are building applications. So I encourage you to go on the Angular 2 documentation at Angular.io and look for their section on routing, which is pretty comprehensive. Somebody asks, when would a developer choose to use view encapsulation none? Is this where global branding styles might be added as independent component? I would personally say that I have never used none, because it's, it turns off all the nice encapsulation. What I would use is the default view encapsulation emulated, and I would include my branding, colors and fonts and global things like that in a global level style sheet that I would just hook up to the HTML page, using the normal means like a link tag. And so with view encapsulation emulated, which is the default, all the components will get that global style sheet, but they won't affect each other with their own internal styles. Somebody asks, can you use Polymer components in Angular 2? To be honest, I have not actually tried that. In theory, it should work, but I haven't tried. Somebody asked, do you suggest a different file naming convention for presentation and container components? I actually tend to put all my presentation components in a components folder, and then I put all my container components in a containers folder. I'm not sort of dogmatic about that, but yeah, I do like to be able to quickly see which are which, typically because container components tend to be sort of page level entry points, and it's convenient to be able to locate them quickly and easily. So with that, we're just about out of time. I'll see if I can do one more question. Somebody asked, can we do Sass and less with Angular 2? And the answer is absolutely. You have to, I guess, work out your tool chain. If you look at our boilerplate app on Wrangle's GitHub page, the Angular 2 Redux starter at github/Wrangle, we don't use Sass or less. We actually use something called CSS Next, which lets you do CSS4 syntax today. And we use that using a Webpack and a loader called PostCSS, which allows you to transpile your CSS in a similar way as you would do with JavaScript. Now, I know for a fact that PostCSS has support for Sass and less loaders, so that would be a relatively straightforward way of doing that. And so then what we actually do is we will require the CSS directly into our TypeScript code and assign it to the styles property, and that will cause Webpack to run it through whatever transpilations you specify, including other useful ones like auto prefixer, etc. So I encourage you to look at our boilerplate where we've got a pretty robust toolchain set up there. All right, well, we're out of time, so thanks for coming and listening while I talk about Angular for an hour, and hope to see you again.